Hello everyone and welcome to building Budgie number 6. My name is Josh. I'm the lead of Buddy's a Budgie, developers of the Budgie desktop environment for Linux and BSDs. Right now I am working on Budgie desktop services, which is a core component of Budgie 1010, which is our Wayland based GTK3 implementation of Budgie desktop. So this is like the main implementation that is then ported over to Wayland, as well as Budgie desktop services applying to Budgie 11, which is our fundamental re-architecture and rewrite. So not just a port, but a complete rethink of Budgie in Qt 6 and C++, as opposed to GTK3. And the core aspect of Budgie desktop services is the output management. So what I mean by that, which I am. Let me switch my mouse and keyboard over here. Is output management. So what output management is on Wayland, you don't really have a concept of like persistent configuration of outputs, at least on like WL roots. Of course, you might be able to use like third-party tooling, for example, Conchi, to write your own config and then have Conchi apply those every single time you start up. So I had implemented a similar thing to enable Budgie 1010 persistent configuration, and then you could change your monitors using W displays. And this has been all well and good, but of course for Budgie 11, we are not actually going to be using WL roots based compositor. We will support them, but our compositor that we are developing is going to be Mir based, and Mir does not support the WL roots extensions required, or the protocols required for output management, or for getting output information through WLR to begin with, which is done through the WLR output management protocol. But fortunately, every compositor supports, it's just called WL output, which is, if I go to WL output here, you could see it has information like the model, the name, the description, manufacturer, and you're also able to get like mode information and that sort of thing. So that is effectively what we are currently implementing, is support for that in Budgie desktop services. So the generic WL output interfaces, and trying to do that in a way where we have a generalized set of interfaces that all support WL output. And this is sort of the foundational ones. And then you layer on top of that, for example, the supplemental functionality from WLR when that's available and supported by the compositor. So this enables us to ship this version of Budgie desktop services for 1010, as well as leverage it for our Budgie 11 implementations. And that is going to be particularly useful for our work on Budgie Shell. Budgie Shell being the sort of graphical aspect. So, you know, like we have Raven here, right? So we have, that's our side panel with a bunch of functionality. You have your panels, you have Budgie menu. This is all shell components, and you kind of need to figure out, you know, if you want to position it on your main monitor, well, it has to know what those outputs are to begin with. And if I pull up our Magpie compositor here, which is written in Mir, you could see that I am in fact on Mir because it supports Mir shell here. And if I close out that and I do WLR, you could see that it doesn't support those interfaces. So the idea is within this shell, you'd be able to properly position Budgie. Well, within this compositor, you'd be able to properly position all the shell components for Budgie 11. So I did a lot of work on that in Budgie desktop, in building Budgie 11 number 5. So some of the work that I did related to that was implementing some of this generic interface for our concept of metahead, which is think of metahead as it stores information regardless of whether or not the head comes and goes, whether or not you unplug a monitor or plug it back in. the head information will remain. So that way you can leverage dbus reliably to, or you theoretically would be able to enable leverage dbus in our batch system to get information and to re-enable the head if necessary. So I started working on all the interfaces for that, and then I've been leveraging K-Wayland, which we had already been leveraging for Budgie desktop services for the registry and connection thread stuff. So basically keeping a main loop going and constantly getting events from the compositor. And it actually supports WL output and provides a very handy wrapper, a cute wrapper around, well, many aspects, like many protocols, but one of the key ones is the K-Wayland client output. So, and that is the WL output. So that is what we have been leveraging. I did a bunch of work off stream on this as well. Let's see, some notable things, individual setters. So I have these individual setter functions because I wanted to more properly control when we actually emit state changes, as well as when we handle or when we output a request to save the current state, basically the file that we have for the shim, our shim mode in quotes. And I will display that in a moment. So we have a bunch of different like queue properties here. I remapped some of them as well off stream. Bunch of different setters. These we had already ported over from the WLR meta head. I added a bunch of different properties so that way we could expose those, and shifted some of the type deaths as well. So I also came up with this batch emitter, which is a class that enables you to sort of do two things. If you have a batch ongoing, which basically communicates that we have like a depth of work, that it basically ensures that all of that is completed in the function that you provided. So if I go down to the update output properties that I implemented off stream, you can see I called this batch function, and I perform all these different things, all these different set properties. And then when the function exits, the depth is reduced and we flush. So here we have all these marked dirties. So if we weren't doing this in the depth here, it would immediately trigger this function that I have up top, which is this function, literally this, where we emit the state change and then the shim mode. If we're in shim mode, then we save the config. And if what that is intended to do is reduce a lot of noise related to state change. I wanted to basically only do one state change call and one config save when we do an update output properties. And we do that in a few scenarios. So we would do that when we first get the output and listen on the changed event. So that would trigger, I could actually show it up here, the set output, where we connect, and then we immediately call the update output properties. And then whenever the output actually changes, so one of the property changes, we recall it. And that will just go through, it'll check all the different properties, and it'll update them. And something handy that I did here is I actually have comparison checks now. Before we were just like taking a value in and just immediately setting it and calling state changed. But for example, if the name didn't change, why would we communicate that there's been a state change and that the name changed when it didn't? So it just is trying to reduce a lot of that extra noise. So I did that off stream. What else? Output management work I did a little bit on. Nothing really to write home about there. Yeah, nothing too crazy that I did there. I did some work on just trying to make sure more of it didn't have errors everywhere. Yes, I cleaned up the So we have a WLR head, which takes in the ZWLR output head, like the pointer to that, and saves it as the MWLR head as a private member of this class. And we have a bunch of these overrides that we do so that way we can emit these state changes when we get information, because the way this protocol works is it sends information about the name, the description, make, model, etc., all as individual functions, as all different protocol events. So you have to listen to all of them and then emit the properties. So I did that, some cleanup related to that, and some more of the code. And also did the same sort of cleanup in the WLR meta head, which I will likely retain some of this because we need to actually handle the individual output modes. So the work that I'm doing today is going to be primarily related to output mode and the meta mode, really. Because right now it's all tied into the WLR, and we need to sort of have a generic interface for this, and then layer the WLR one on top of that. Because in theory, I haven't really checked. So if I actually do a quick change here in the meta head. So it was on. Actually, I should be able to do this. Output mode. Aha, here it is. So they have just a basic struct that they output. So whenever we have a mode added, so I believe that when it does the initial dump of all the modes, it calls mode added. And then any mode that has changed will then subsequently get a mode changed. So we have that. So there's a struct in K-Wayland output. So that's where that lives, where we have the information on if it is the current mode, or if it's preferred as well. So you could have one that's preferred and current. I don't know how they dictate whether or not something is preferred. I need to look at the code for that, I guess, at some point. It has the size, the refresh rate, and the flags, which are these. And then it actually has a pointer to the respective output. So this is actually kind of nice that it references back to the output, because that's not actually something that you get with the ZWLR one. So that's quite handy that they did that. They have some of these, but that's outside of the struct. So it looks like it's a pretty basic struct, but it does have all the information we need. So quite happy about that. And we'll be able to easily confirm whether or not something is, well, we'll be able to easily determine if something is the current mode. Of course, it's using like the flags, which always trip me up. So, well, I'll probably stumble on that for a while, but that's okay. Let's go ahead and increase the volume a little bit there. And we are going to get to work on that. So we have our WLR head here, our WLR mode, I mean, for the meta mode. We are going to create a new top level one, not a folder, called meta mode.hpp. And we are going to include, we're actually just start off with it being a namespace. If I could even type that, off to a great start, bd outputs. And it is going to be a class of meta mode. So the reason why I'm doing this immediately before these, actually I don't even technically have to, I could do this and then just move these after the definition. That's what I did for meta head, actually. I think it's kind of cleaner. So let's just rip that out. So we're going to have a class called meta mode, which is going to be a public queue object and protected. So we are actually going to yoink all this. And we are going to pull in these two. Actually, probably queue size, queue string, queue variant. I don't know if we'll do optional. but we'll do at least these. And also I just want to double check the volume on, let's see, check the volume here. Volume there is fine. Let me go ahead and increase it there. I have to use my USB switcher every single time I want to swap back and forth between. All right, so I do actually have audio there now. Cool. All right. So we need a public meta mode. We're just going to take our Q object. And then it's actually going to take our K-Wayland client output mode. And is it a pointer to it? Yes. Like so. I don't know if we're actually going to need a destructor here, but we'll override it. Actually, I think we could just do delete. Delete? Yeah, we'll do override right now. We have a bunch of getters here. Available, current, height. I don't think we have availability information. Removed. So that's for the actual output itself. We don't have anything for the mode. Because it's just a struct, it doesn't actually have any other information. So we're not going to have available. We will have current, height. ID is a funny one because, well, it's like, it's just a string of the information. But whatever. Preferred, refresh rate, and width are all good. We're going to rip this out as well. So my line of thinking here is that we are going to have most of this in the actual sort of base class, the generic one, and a lot of the functionality in meta mode for WLR will just be handling the ZWLR output head or output mode. So do we even need this? I would prefer just to have them be as 0, queue size of 0. We're not going to have that. We don't actually even need the related, I mean, I guess technically we could do this. But we could have in the mode itself as a queue shared pointer to meta mode, and we can call it mode, something like that. We have this. Oh, these, I don't know if these actually need to be virtual, but we'll set them as virtual. So let's see, is this gonna work? Oh, this does work. I'm sure there's a very nice keybind I could use for this, but I don't typically I haven't really bothered to learn any. So we have this. What am I doing wrong here? Oh, it's because it's public and it's like this. I'm actually going to turn the volume down for myself here. There we go. It shouldn't affect you guys. That way the music isn't so loud in my ears, but it still comes across as fine for you guys. So we have size. You know, I kind of am tempted just to have size instead of storing the, like having individual getters for this, but it is quite handy for this. Ah, yeah, that was actually something I changed for the meta head, I want to say. If I go up here, where was it? Ah, geometry, yeah. So I have geometry here, which just has a key rect. I think I'm going to do the same here. We'll do Q property. And it's going to be the queue size. And it's going to be, I mean, in a way it's geometry. It might just be better to say size. Read size. And then we don't need these, like the width, the height. Let's move this down over here and we'll do size and rip out. So we ripped out height, which is good. We have is same as. I don't think we need that. We do need the registration. We'll set that as virtual as well. And we'll move this actually up here. We have a set mode. I don't think we need that. I mean, there will be mode change, but I think that's... So whenever a mode changes... And how would it change though? Because I guess it would change by like the flag would change. So we would want a, I guess, a public queue slot. So we do queue slots, and it would be a, I think it has to be like this. Public queue slots of virtual mode changed. And it is our mode. So I don't really need a virtual void as well. Of course, it's... yeah, but it's on the top level of output. So this wouldn't actually work. You would need a function for update. I mean, I guess it would just be virtual void set mode. Wayland client output mode, like so, and that would just repoint, and then we would have a protected queue shared pointer. And this is exactly why I have the type defs, because this gets like typing this over and over, it gets old very quickly. So that set preferred, do we need the setters for it? I guess if we want the signals for when it's ready, then we would want that. We would want all the different setters. So we'd have these getters. And then we would have setters. So we would have the, I don't know why set does that. It's really annoying. We'd have a void. Set current. I don't think we need a dedicated set current because setting mode would do that. But I guess if we want the changes, we would do set current as a bool current mode bool of m mode, and not m mode, m current. Yeah, that we would want void set ID. I don't think we want the refresh rate would be set preferred. Bool preferred. Void set refresh rate. Wait, so if it has preferred, where is it getting this information? How is it dictating? I gotta look up the actual Wayland code for this because I'm quite curious. Wayland client, I would assume. It's gonna be output preferred. So we add a mode, WL output mode preferred. What? It doesn't really have preferred. There's no way. If I go clear down here, WL surface. WL data. Oh, hold on. Geometry. Preferred buffer. No, that's not right. Preferred buffer scale. I go down to W output. Indicates is this is into the preferred mode. Yeah, of course. Duh. I don't know why I was thinking preferred output. My head's been so much into the outputs and meta head stuff that yeah, preferred mode. Right. Yeah, that would be valuable to have. A refresh they have as a int. Sure. I want it to be a QU long of refresh. Just to really make sure we support stupid sizes. And then the next thing would be, I guess, the size. Void set size as a queue size. Like so. And then set mode, we call these. All right, so now if we take a look at our signals. Signals, queue signals. So we have preferred change, refresh rate changed. All that is good. We have done, which is, I guess, when it just drops off the face of the earth. We don't have a concept of that. We have a concept of mode added and changed, not mode removed, because, well, that doesn't really make sense. Unless you're like modifying the information, like what EDID information, like what your monitor is reporting it. Maybe I could see that for like Elgato's, but even that's over UVC. So yeah, I don't think we need a done there. Availability changed. I guess whether or not it's available. That would be useful. Although, if we are only getting all the information all at once about a mode, then when we create it, we have all the, yeah. Well, we'll keep this for now. The size of it shouldn't change, though, ever. Refresh rate shouldn't change. It would be preferred, and I guess void current changed. I don't know if we'll need that, but it might be something useful eventually to plug in. Mode disconnected, I'm not going to worry about that. MID, yeah, so we want all of these to be stored as well. So we have current. Reduce the size of this. We're going to have the queue string of MID. And we're going to have we're going to have pool of M preferred. I know I could just store the flags. I don't want to though. I don't want to think about Q long M refresh rate. It's called refresh Q size of size. M is available. Well, I mean, if these are just, well, I still need them for the C++, but like in reality, you wouldn't need them if you were just doing queue properties. You would just be able to put in like member here and then the setter. I don't, it might be that in the end, I end up ripping all these out, but my line of thinking is if I need something for, if I generalize this enough and then libify it, I still need to figure out how I'm going to model all of this, but my line of thinking is the shell doesn't need to quote unquote speak dbus fully. It's just that the interfaces themselves would speak dbus, something like that. I haven't thought that far ahead. So maybe having the queue properties for like the graphical stuff is still useful. Mode, set mode. We need something to... I had a function here. I think it's same as that, yeah. I'm not gonna implement the function here for is same as. Let's see, let's create the C++ file, metamode.cpp. We're gonna include metamode.hpp. I'm gonna do namespace, bd outputs, like so, and then we have the meta mode queue object, and actually this should be this order. It always rubs me the wrong way when it's the opposite order, because I hate like doing the null pointer at the end. We do this mode. Why isn't this? Ah, right. There we go. That'll fix that queue object. All right, so I cannot redeclare mode here. Closing outputs. Output mode. Let's see. Let me take a look at that. The OG WLR1. Namespace BD, yeah, so it's the correct one. Namespace BD outputs. We have a class meta mode here. Oh, right. Derp. There we go. All right, so we will set the M mode as a queue shared pointer of K Wayland client. All right, this is gonna actually drive me insane. I'm gonna do this. Type def K Wayland mode is this. Or is it this way around? Yeah. And then anywhere where we are doing this, I do that. And we're gonna do type def of a queue shared pointer to K Wayland mode is a K Wayland shared mode. And then we will search for this. It's up there as well. Okay. There we go. All right. And then this could just be like so. And M mode is going to be a K Wayland shared mode of mode. Why is this type specifier for all declarations? Yeah, I guess you probably want queue object parent. And it needs to be like this. So we specify M mode. It's complaining about the null pointer stuff. No matching conversion for function style cast from K Wayland shared mode pointer. Oh, are we doing still pointer there? Oh wait, no, this is this is just K Wayland mode. That's why. That's why I was complaining about all the things as well. So we have M mode. We also are going to want M current is something we have to set. And M preferred. We have to set those. Like so. Bool is not function, M current. Uh-oh, I broke something here. M string, M mode. Yes, I'm missing that parentheses there. All right. So that is that set, literally. We want our getters. I wish it would stop doing this. But we'll have to do it like this. All right. Have a bool current, const. And we don't actually need to define it like this, I don't think. Return M current. Meta mode, like that. There we go. Bool of meta mode ID const is going to be MID. Of course, it's a Q string, not a bool. We need so we have available as well. We need that, which is a boolean or a BPP semicolon apparently. Meta mode available, which is going to be M. Oh, we don't actually have available. Well, maybe we don't actually need that. Let's rip this out. All right, current ID preferred, which is going to be a boolean. Const M preferred. Refresh rate, which is our Q U long long. Q U long long meta mode. Refresh rate. And our size, which is not an int, it is a Q size. That getter was not correct. Q size, meta mode size. Const, turn M size. All right, so now we have the setters, but we have the getters. Now it's time for the setters. And this is going to leverage our same batch system, I think. I'm not quite sure how though, because I guess if we're getting information, well, I guess what we could do, we'll take a look at meta head, not WLR, a generic one. Oh crap! I keep freaking. All right, this one. All right. So we have state changed. We have a thing for getting current mode. And if I check metahead CPP, we do have a thing for current mode, which is right now the shared one. Actually, now that we have this fixed, let's go ahead and rip out all of these. So this is just going to be that. And wherever we have WLR meta mode, we're just going to rip this out, boop, boop, like this. Shared meta mode, which I believe I defined. Oh, I didn't actually define it here. Type def. We are going to do shared. We'll do shared meta mode, which is a Q shared pointer. of meta mode. And we're going to type def of meta of queue list of queue shared pointer meta mode. Oh, I don't even need to type it out like that. I'm going to do this shared meta mode as meta mode shared list. So those will be defined. Yep, those are cleaned up. Let's search where else. We don't need these. Oop. And this. That does mean our functionality in meta head is going to be busted for a moment. I think that's probably okay. M output, M identifier, M output there. Let's see. We could have it. So M current mode, yeah, is the shared one, which is just from the list. So we could have it where whenever current changes, we don't need a batch for it. Okay. I've come to that conclusion. We don't need a batch. What I will do though is meta mode, set mode, a bool current. If M current equals current, return. Otherwise, Q debug, setting mode ID as current. And then we will do M. Actually, what pattern have I been doing? Have I been doing it with... Okay, I have been doing the assignment and then I feel like that's bad. I'm gonna do it like this. I'm bucking the trend that I set. And we are gonna emit current changed with M current. We do that. And we will do void meta mode set preferred. Full preferred. And it's the same deal here. M preferred is equal to preferred. Return. We'll just return Q debug setting mode ID. Although, funnily enough, we don't actually have that reference to the meta head. I think we actually do in the WLR one, if I check. In the constructor, yeah, I guess it would be the parent that we're doing it as. Of course, we don't know that it's the meta head. Wait, but we will. Yeah, fuck it. We don't often do that, so we'll do BD. It might actually be as easy as BD outputs meta head equals parent. Setting mode ID on output, and then be head identifier. That's preferred. And then we'll do M preferred is equal to preferred. Let's actually do the similar logic here. So you grab this. like that. That way, whenever we do the debugging, we know what what output the mode is associated with. And we need it for next is going to be. I can't be bothered to do this again, so we're going to do the set, refresh, QU long, refresh. I don't think I'm actually saving any time here, and refresh. But you know, it's a nice idea. Setting refresh. 2. Setting it to refresh. We haven't actually done the assignment yet. And then M refresh as refresh. Meta mode. What's the size? Q size. Size. We're going to do a couple things different on this one. So if the size is, if it's empty, we're going to return. And I believe the Q size empty is if both of the values are 0. Or it's that if, I think it's if one of the values is greater. Let me see Q size. It might be if they're both 0. Is empty. Returns true if either of the width and height is less than or equal to 0. Okay. So if it's empty, we don't want to set it. If M size is equal to size, we want to return as well. Otherwise, we are going to get a parent. And actually, could it be that? I mean, it's a Q object. Yeah, we'll keep it as Q object. Q debug. Do it like this. Setting size 4. Setting refresh 4. ID. But of course, it's a bit of a chicken and egg problem. Well, I guess if we do in the construction, we call set mode. Actually, yeah, we'll want to do that instead of M mode like this. We'll do this. Set mode of mode, because then that will actually be the thing that's responsible for creating the ID and then doing the calls for all the different setters. That'll work out fine. Fingers crossed. So we have those. I'm not going to do the registration yet. We're going to do the void meta head set mode, which is going to be the K Wayland mode. Which is K Wayland mode pointer. Those should match now. Of course, it would help if I did meta mode, not meta head. So the first thing we want to do is set M mode as equal to the shared K pointer, which we might not have. Q shared pointer. Oh, I do have it. I have it as K Wayland shared mode. Whereas I think the others I have as shared and then something. Yeah. This should be shared K Wayland mode. What is this complaining about? Declared here. Okay. And then here. Like so. And we'll do this mode. So that'll set the mode. And then we will have all the different properties of it. At least we're operating under that assumption. It's going to be a real pain in the butt if we're getting incomplete modes from mode added and mode changed. So I'm operating under the assumption that K. Wayland is doing things correctly, which might not be the case. But we'll fix it at that point by doing like validity checks or whatever. We're doing the same thing that we do for the current WLR meta mode. So we have this, we want MID to be a Q string of, and there's nothing particularly fancy. We'll actually rip it out from, because I can't be bothered to do it again. I think it's set identifier in, let's see, in here, meta mode CPP. Where are we? MID is equal to, here we are. Literally size, yeah, this kind of stuff. Yeah, it's gonna be like, what is this? Mode.size. And this is gonna be mode refresh rate. So it's gonna be refresh rate, size, height, width. That's literally it. Although this is going to be that, so I want it to be a QU long. Although that is actually, no, it's an int. Okay, it is an M hertz. Good. So that would be correct. And what we could do after this is then now that we've set the ID, we could set current is equal to the mode flags. I think it's equal to what? K Wayland. I forget how the whole frickin' flag thing's like. Let me check the documentation. Q flags. Hopefully it has docs. Let's see. Set alignment as left and align top, but what about the like equal Q flag equal stuff? Isn't it? Oh, where am I doing the flags? Q flag. I feel like I'm doing it somewhere. Q flag. What? Why not? I could have swore I was. Oh, I'm doing it in, I think I'm doing it in Budgie shell. Q flag. Cool. Oh, no, I'm doing it in, I know where I'm doing it. Let me pull this up. I'm doing this in Magpie. That's where I'm doing this. It's coming back to me. Q flag. What? Q declare operator. Yes, here it is. For all of these. Yeah. So we have all these Q declare flags. And then in my launcher, I have it, I think. Did I move it to keybind? Key sequence. Window policy. It's been a while since I've looked at the code. Yeah, KFCG, input focus mode, that. And then it is handle pointer event. Mirror input event modifiers. Keybind config. Is it in main? Yeah. Get actions, run action. Oh, we're just doing the sequencing stuff. Oh, that's annoying. Okay. Well, whatever. I'm gonna assume it's like M flags, something like this. This is probably wrong, but client output mode flags. Gonna be flags. No, I think it should be this flags. Where's the current? We have int? No. Enum type? Enum type current? Oh, I don't know if that's right. I'm gonna actually just Google it. Well, catchy technically. Q flag, check if flag contains value. Check if flag contains any other flag. Okay, it is the right, is the ant. Yeah. It's always something that's confused me, which is why I try to avoid these. Set preferred is if mode flags Wayland client output. Oh, hope if I spell client right. Output mode and it'll be flags preferred enum type preferred. All right, and then set refresh rate as ref and set size as equal to size, which is SC. Like so. All right. That will then update all those, emit all those changes, which will then determine if it emits the current change and preferred change. Availability change, we'll set it to true. Now that all those have been set. Which I think is it. I think that's all the setters. M current would be set as the current. ID mode, which is literally the mode. So that's fine. So yeah. Oh, did I actually implement the getter from mode? I did not. So that is going to be the shared K-Wayland mode. Meta mode const and turn M mode. There we go. So we have all that implemented. Now it's going to be the register dbus. And we're just going to rip that out from register from here. Aha. So this is going to be after all this. Extras. We'll just call extras. Why is it doing it like this? Can I do like control enter? No. All right. Q dbus connection. We are missing that. So let's bring that in. All right. And then we have all that set up. So we have the ID. We get the head. So we do our Q object cast of parent. Okay. Pointer of that. Right. So we actually might want to change our behavior here then. Like this. Refresh. Oh yeah. Setting size to oh yeah, this will. I don't want to use the Q string like arg stuff, but might be easier for me to do that. Pass a Q string into a Q string sort of thing. No. We're gonna do it like size, width, like this. Is dot width. By size dot height. Like that. Oh, funnily enough, we weren't ever actually setting M size is equal to size. Alright. We have that. Meta mode size. All this stuff. Let's fix all that. Because, yeah, it is a pointer, so we can't cast it directly to a non one. Rip that out as well. We don't need that crap. It doesn't know what meta head is. Well, that sort of does. Yeah, it kind of poses a problem, doesn't it? Because meta head would then have. How do we solve it in our meta head? Did we just write the class? No, it was. It was circular. All right. Hey, if it works. Meta head. And then it's identifier. That needs to be fixed. Needs to be fixed here and here. Like so. Okay. So we have registration done. We have set mode done. Oh, there's 2 debus struct, which is all this stuff. Okay. Well, fortunately, that is easy enough to do. Like so. We have M preferred, which is going to have a value. So it's just M preferred. We don't have information on current though, which is interesting. Bool. Current. ID with height refresh rate preferred. We'll also do current equals other dot current and that. Okay. So that will return that debus struct of output mode info. We have the preferred. All that's actually implemented as well. Let's see. Did I not implement set? Oh, I do. I just didn't emit preferred changed of M preferred. So I have the current emitter set current. Yes. So I have those two. I have the availability changed, which is more just that is ready, right? Like it's not magically available. All right, so we have that implemented, which is great. Now what we need to do is tweak our meta head, I think. We have output state, virtual function get current mode is a different, yeah, so get current mode has shared meta head. Wait, what do you mean? In state. Group? How far down is this rabbit hole going? What the hell? Meta head is then getting. Alright, so that's just all busted. I'm not gonna worry about that then. So those have been changed, and then WLR. Rip out WLR here. Meta mode. WLR. No reference to WLR. Are we leveraging state? We are for a config state. Okay. So that'll need to be updated. But the next thing is going to be updating our WLR meta mode. And then, well, actually it should be updating our existing meta head, I think. Our generic one. So I'm going to close all these because having these open. And I'm going to do this there. I refresh. All right. So this meta head. So we need to listen on when we have a connect here. First I need to set this music all the way back to 0. There we go. Just double check the volumes again real quick. All good there. Yeah, it seems all right. Cool. Right, so we have our modes, which is a map to mode info. So we're actually inserting to the dbus struct and then returning all those as modes. Not sure really what to think about that, but sure. We have one for current mode. We have current mode, which is returning the shared meta mode, but here it's returning mode output. Am I looking at their meta head? How is this not being flagged? Because this is current mode. This is right. Oh, we haven't implemented the get current mode. Right. Oh well, we should do that then. So this is going to be here as a shared meta mode. Meta head : get current mode. Although I think it actually should be after all of these. Or before here. Ah, here. So we have that. And this is going to return M current mode. And then get mode by props. So this is going to be a shared meta mode, meta head of get mode by props. Now, are we storing? Okay. Shared list, good. And there's going to be int width, int height, and a long refresh. The first thing that we are going to want to do, I mean, could this take in, where are we using this? We are using this in model to get the dimensions, which is already a queue size. Bro. Oh my goodness, we could just do this. Queue size. I do. Queue. Trying to do a shared meta mode. Trying to have a call result. And then we're going to iterate over the auto mode of M output modes. And if the it would help if this was size and size. Like so. If mode oh yeah, I guess they are all pointers. Pointer to auto mode pointer dot value. Isn't it value? Oh, I guess it is just inherent value. Okay. Mode. Yeah, it's mode data. I don't actually know if this will work, but all right. Mode size is equal to size, and mode refresh rate is equal to refresh. Then we will do result is equal to mode break and return result. So we do that. Get modes is the shared meta remember to sit up straight. Meta head. Get modes. Return M. Output modes. Just do literally like get modes. Or like Y. Alright, so we have those. Do we have the add mode and remove modes? Add mode. So we don't have anything for add mode. I mean, I guess if we just have it within the handling of set output. Yeah, so we have this. So on changed, we do connect M output K Wayland : client output mode added. We do this, pass this along. As what mode? This mode? Or do we have access to mode within this mode? Mode change const K Wayland. K Wayland mode. Like this. Then mode should be that. Yes, it is. All right. So when we have a mode added, I would like to think all the information about the mode is complete, that we have all the information. So what we could do is construct a new meta mode from new, I don't think I need to do that, meta mode. Oh, maybe I do. New meta mode, where it's going to be mode and this. This is the parent. This should be a pointer to it, which it is. That's fantastic. And then we will want to connect. Oh wait, no, we won't. We won't have to connect. Thinking here. I think we only have to add, because yeah, it doesn't have anything to connect to. It's a struct. Keep forgetting. So we just need to add it. So I'm going to do M output modes dot append a new shared meta mode of meta mode. So easy enough. When a new mode is added, the output add. Now what I'm curious about is, are we going to get that? Are we going to get that first announce, or do I need to iterate over them anyways? In which case it might be good to almost have a safety here, if that makes any sense. So we would want an add mode. Like we have unset modes here. Virtual void add mode. We're not going to have a remove mode, but what we will do is split this and go down to unset mode, which we didn't implement. All right. Great. And this actually needs to be a slot now that I think about it. Q slot. Virtual void add mode, which is going to be a shared K Wayland mode. No, it's just actually just a K Wayland mode. K Wayland mode. Like so. And so this is all setters, and then we have slots. Oh my gosh. We're going to have a void meta mode, meta head, add mode. It's going to be a K Wayland mode pointer. We're going to want to check if it matches. So we're going to do probably our get current like this. Auto mode existing mode is equal to get mode by what am I doing wrong here? Void add mode. K Wayland pointer mode. Function definition not allowed here. Why? We're in the class. Void meta head. Add mode. What? Oh, it would, because it was, right. Get mode by props. For some reason, I thought that was like the end of the class definition, but no, apparently it wasn't. So we try to get the existing mode, which is the mode size, and mode.refresh. So if we do have one, so if existing mode dot, if it's not null, existing mode, there should be one for like if it has a value. I guess it's just if it's not, if it's not. If it's not null, we return. So already have the mode. Otherwise, we will create it. So we'll do this. And append. I also want to volume. Let me go ahead and reduce the size of this. Yeah, okay, so that's a bit loud even for the stream. Got it. Right. There we go. Add the mode. And then what we could do is we connect it to this, where it is just our meta head, and it will be the add mode like so. Just in case modes do not get announced via mode added. During some sort of first announce. We will iterate over them. So we'll do for auto mode of output dot modes add mode. And this should be a, oh, it's a queue list of just mode, and then these are a pointer to the mode in, I guess, in the modes. Oh, that's annoying. There we go. I mean, I could just do it that way, but still, you know. So that would mean it's already in the list. So we're effectively just adding it to our list. We're making our meta mode with that. So that'll be good. I don't know if we need the availability stuff hooked up yet, but what we want to do is we have the mode changed. So we are going to want a virtual void mode changed, which is a K-Wayland mode. And what we could do here is if I connect up this to m output data, and it's going to be the K-Wayland client output mode changed event. And we're going to do meta head mode changed. So our own mode changed. And on our slot down here, we'll have a function meta head mode changed. No, not model changed, mode changed. Thank you. K-Wayland mode pointer. We will get the existing one. So actually, do this. K-Wayland mode. So if existing mode is null, then you're going to want to existing mode is equal to, we'll do this, new mode is equal to new meta mode of mode in this. And we'll set m output modes dot append shared meta mode of new mode, and actually this needs to then be existing mode is equal to our newly constructed shared one, and then we append the existing mode. So basically what we're doing is handling a case where I don't think this would happen, but we get a mode changed for a mode that we don't have yet. So in this case, we just construct it, and then I guess we check if that is the current, because I mean that was the goal, right? Is we do this if existing mode so we now know it exists. It's not null. Is current. Although we still could then do like a safety check of if existing mode is null, return still somehow null. Like that. Maybe we could do it in here, but not too worried. Still somehow null even if we construct a new one. We do this auto meta mode is equal to existing mode dot data. I don't know why, I just feel more comfortable calling it like this. So this mode is the current one. So that is on the mode changed. So if the existing mode we found, no, actually, we would want to get auto. So the logic that I'm trying to implement is a behavior change for when the mode itself has changed. So for example, if the current mode if the mode is no longer the current one or the preferred one, in that case we would want to flag that, update our values, unset the other ones. So in this case we are going to do it like I guess we need to get the current mode is equal to it's equal to the m current mode. But of course, this is just the shared one, right? It can be null if this is our first go around and we haven't set a current mode. In which case, a lot of this logic would need to be in... Oh, actually, it would need to be here. When we add the mode, m current mode, we would have to do this. If meta mode dot, if it's current, if this is the current mode, m current mode, meta mode. Ah, no, it'd have to be this. Auto shared meta mode. This and shared meta mode. And then shared meta mode here. So that would set it as we're adding them. So if my hypothesis of there isn't a first announce would be correct, then when we add the output, we iterate over the modes. And then as we're iterating over, if it's the current one, we immediately update that it's the current one, like we flag that. So we would do the current mode changed, I think, as a signal. Yeah, current mode changed. Current mode changed is, oh, it's the output info. That's interesting. Current mode, sure. We would do meta mode to debus struct. Emit the current mode has changed. So we would do that on add. And what's great is if we somehow didn't get this announced, but we got that brand new mode here, when we do the add mode, which actually we're not returning it. Let's do that. It doesn't hurt to do that, so we will do shared meta mode. This is going to change the behavior of this and return shared meta mode, like so. What we could do is existing mode is equal to add mode on mode. Add the new mode and assign to existing mode. Then if it's null, at this point, we'll know if it's the current one. If we don't have a current mode, dot is null. We'll do this. If we don't have a current mode, and this mode is reporting as current, then we will immediately assign m current mode is equal to, I guess it would be existing mode, and emit current mode changed as the current mode as meta mode. Meta mode to debus struct. So same deal here. So if the current mode is null, we could do it. We could do it like this. Rip this for now. Have this. Or, so if current mode, I mean, I guess it doesn't matter if it is the current one, but I guess the logic is if the modes weren't the same, in which case we would want a convenient is same as function, which is probably why did it here. Let's see. So we're going to do meta mode. And we're going to do the getter. It's not really getter. It's more like this sort of virtual bool is same as meta mode. Like so. So it's the same as itself. Oh, void meta mode is same as. Oh, it's not void. It's bool. Meta mode. This would actually be a pointer to it, I think. All right. Oh wait, no. I guess the Q shared pointer would be the pointer. Mode. So we would return this the same as if the M size is equal to mode size and M refresh is equal to mode refresh. Wow, I really butchered that one, didn't I? Refresh rate. We could even do it like this: size is equal to refresh rate, like that. So if the current mode is not null, and the current mode, so we do this, current mode is not the same as meta mode, invalid conversion of the pointer, the data is, oh, it is a pointer, okay. Do like this, mode. Which case it would be mode size like this. All right, so if the mode is null and the current mode is, and the mode that we have incoming is current, or it's not null and the current mode is not the same and meta mode current. I mean, really, we don't even have to do it here. Because like on the mode changed, get the existing mode, otherwise we add it. If it's null, whatever. Get the meta mode. If meta, and then if it's not current, return. If it isn't the current, none of the mode change logic matters. Because it's related to that. So we don't even have to do any of this. So we could just check if it's null, or see if we don't have a current mode, or we do, and it is different. If current mode is null, is that, and we have all that logic, and then we emit. I really want this to be on a new line, but it's really don't have a current mode. If we have a current mode, have a current mode and it is different to the mode that just changed, we do that. So that would update our M current mode and then emit the mode changed, which would be the debus struct there. Oh god, we have to do the same for preferred change. Oh no. Well, we could do it like this. If the meta mode is reporting as current, we do it like this. Current mode logic. Do it like this. This seems kind of dumb. I'm not gonna do that assignment. All right. If preferred change, I mean, we're not even saving the. Are we even saving current mode? Or are we saving this? Where is this ping set? Shared meta mode. Meta head. Oh, because I'm looking at the wrong freaking thing. Like, what? How could it exist but not exist? Okay. Shared meta mode and preferred mode. Something like that, I guess. And then we would want to save it be on add mode. Add mode. Same deal here. If meta mode preferred. If this is the preferred mode, we do m preferred mode is equal to shared meta mode, and then emit preferred, which should be preferred. Current mode changed. Oh, we don't actually have one for preferred changed. Okay. It's just current. Debatable if we actually even need to save that then, but okay. I guess it doesn't hurt to add it. Preferred mode changed. I don't know if I like it being that though. It's that output mode. I think it's because current mode changed is hooked up to dbus. Yeah, it's still hooked up to dbus, and we can't send the meta mode over the line. I mean, I'm sure there's some fancy pants like dynamic marshalling we could probably implement or something. I don't, but I'm not gonna. All right, so we'll do it like this. Preferred mode, like so. Preferred mode is equal to meta mode to dbus struct. Of course, if it's current and preferred, we're doing the dbus struct thing twice. But the preferred mode has changed. But, you know, whatever. Notify primary changed. Oh, I guess we call it primary and not preferred. But what does primary hook up to then? Of just bool. Oh wait, no, because it's primary output. No, not primary mode. Okay. Or preferred mode. So that's all fine. We'll do it. We'll do this logic here, which we could probably just blink. So if it's preferred, do this preferred mode logic. If it's current. If it's current and do this. Because then I could rip out this. And then copy this. Could actually copy this entire thing here, I think. And then just swap out the preferred. And then M current, M preferred mode. We don't have a preferred mode. We have a preferred mode. Shared meta mode. Something like that. Fuck me, that is some gnarly nesting that it does there. But hey, it's Clang format, and I'm not going to fight it, so existing mode. Right. So we have both of those hooked up. We have those signals hooked up. What is it flagging here? It's flagging a return of existing mode here. All right. What else is it flagging? Yeah, that whole thing with the current mode. In state. I'm not going to worry about state yet, because our next thing that we are going to do is start ripping out all the stuff related to the WLR meta mode, at least as much as we feasibly can. So we're going to have this little grid here. I'm going to close all of these. We're going to close this. We're going to have our meta mode, our generic one, our base class, and then our WLR one. Oh, too much, too much water went down my windpipe. Good job, me. All right, so we have our WLR meta mode. Dbus stuff needs to be ripped out. Here. Because this is actually going to be based off of the BD outputs. BD output meta mode. No parent. Actually, no, we would. Because the parent of this would be the WLR meta head. WLR meta head, which is going to be that, and then I want the constructor to be, oh crap, I guess a couple things, right? How are we doing it for the meta? This one. Just a Q object. Right. And then we're doing the set mode. Or the set head, I assume. Let me check. Set head. Oh, set WLR head. Yeah, there it is. So we would want a separate thing for like mode, I guess. That keeps the constructor quite simple. Yeah, let's just do that. We'll do this. We're gonna rip out all these getters. For now, I assume we'll have getters, but we'll rip these out. Refresh rate. Get WLR mode is actually a legit one that we need. Preferred is same as. We're not going to do set mode. We're going to do unset mode. What does unset mode do? Sets it as not available. Well, we'll keep it for now. It hasn't harmed us yet. Done. Ah, yeah, the whole... When a compositor, a WL roots compositor, like you unplug an output, it sends done for all those things. So we actually want that. Availability changed. Mode disconnected. Set properties? We don't actually have a set properties here now that I think about it. For the meta mode property. Kind of don't need it. What are we using it for here? Emit done. Oh wait, no, it's our done. It's not fuck me. It's not done as in finalized. It is done as in we have all the properties we need. So that would actually be availability changed. It really begs the question how much of this we even need. You know, like if we're doing the config stuff, I guess configure it. Let's look at the protocol real quick. For WLR output management protocol, you would do enable, and then you would do a set mode which points to the ZWLR output mode v1. So that's if you have a current one. But I feel like we could just, when we're creating the WLR one, you just set the WLR one. Everything else would come from the K Wayland one. And then in the logic for output manager for, I guess in that case, the meta mode for WLR would be even simpler. It would be availability changed, which we have. But of course, again, I have to keep reminding myself, we're not getting this information from, like, it's literally just going to be storing the WLR head, or the WLR mode. It's a little interesting I decided to do it this way, but sure. The const like this. I'm gonna do it like this. Q shared pointer. Now we set the mode. We're even doing it here. Oh wait, no, that's the normal mode. And then that has the WLR mode. Ah, this is a helper. Right, okay. I see. But what does this store it as? I guess that would just store it as the... Yeah, because it's actually a cute Wayland one. So you would have to construct the WLR mode. And then... Or do we even need that? If, again, all it's doing is holding the... Oh, it could literally be a Qt output mode v1. Let me take a look at that code. Yeah, okay. So it's just object. So the meta mode, of course, we don't want it to disappear. Yeah, this is a bit tricky. What does all this code entail? So just the size change where we emit the size change, we get the values, and then when it's preferred. Which then calls an emit on the mode, which we're listening to on. I mean, we're not even listening to finished on this. Like, we have it here, but we're not doing anything with it. Just rip that out then. I mean, ideally, we should clean up after ourselves with regards to this, but I think it's just because we override it anyways. Mode finished, which we don't call anywhere. Maybe we'll keep that mode. Because the K-Wayland thing, that sort of abstracts out what the normal mode would be for us, which is just a struct. And set property. A lot of this is kind of redundant. I really don't know if we need this one. The set property stuff. Meta mode property. Where are we even calling that? Enums, yes. Where else? We are calling it in, yeah, so modes. Mode.hpp. So we can rip out all of this. Right? Meta mode property. Are we not doing it in the config at all? No. All right, so we could rip this out. I think. And then these just emit. I guess those emit the property changed on the mode itself, because this isn't the meta mode. And we'll keep it. But in the meta mode here, we would do set preferred. Like so. As a Q variant bool, but it would be PD outputs, meta mode, set preferred, value.toBool. All to non-static member function. Yeah, I guess I haven't updated this yet. So when we do this, we set mode. Okay, so we create. Yeah. I feel like our set mode would do all this for us. Unset mode if it exists, otherwise we create a new mode, we do the shared pointer, and then we do the property changed. Okay. So the meta mode here can be cleaned up, so we don't do this. Or this. This could be empty. We don't need to specify that. This is a QU long. I don't think we need to specify any of that or that. Standard optionals. That looks out of order definition. Because we are not specifying the PD outputs. PD outputs, meta mode. Indirect base. How am I doing it for meta head? Parent, yes. We do meta head like that. Ah, but of course this is public, yeah, that's right. Let's just save that file in case it decides to. No? Oh, it takes in a fucking, oh, dick. It takes in a K Wayland mode as the constructor, but of course we don't have that. All right. So we need to do it like this. And then in our, I have to fix this immediately, otherwise new meta mode. Do we have a function for set mode? We do, okay. This meta mode, set mode, mode. Fortunately, set the Wayland, K Wayland mode. That'll make things easier. That should fix that. It does. All right. And then we need a function for the setting of, we have set mode here, but it needs to be set WLR mode. It can't be the same. We're not doing any overrides. We have done. We could rip out that signal because we have availability changed. I think. But again, don't need it. Let's rip out all of this just to try to strip this down to the bare bones, which is available, preferred is same as, we could rip out refresh, we could rip out, this is going to be set WLR mode, which will create a new mode and then set up the pointer. On set mode, sure, whatever. 2D bus struct will rip out as well. Mode disconnected. That's the availability change, which we have already. Set property. So this will need to be cleaned up. But that's fine. And then we need to do BD. Outputs, meta mode, set. Set refresh rate. Like this. Like that. Size, same deal. So it's value to size. And we'll do it like this. And change this from set refresh rate to set size. None of the ones, it hasn't changed. We return. Refresh rate has value. We will do refresh rate size, which is UU long. Well, let's say if it's 0. So if it's not 0, actually we'll just do a literal. If it's 0, we return. If the size is, what? Isn't this queue size? Oh, right, let me rip these out. If size. If it's not valid, we return size dot is empty or is not valid. All right. We don't need to do these emitters. We don't need to calculate the IDs. We will now know that it is available. We don't need to do the availability. In my opinion, we could just admit that it's available. Available, we will rip out current is current mode, but again, we're getting that from, we're not going to be getting that from WLR, so we can rip that out. We will literally just have the get WLR, set WLR. We have unset mode, which funnily enough, we don't need either, because this doesn't do anything. Rip that out. We will set availability as false when disconnected, but of course, I think this isn't hooked up to anything either. All right, we're just ripping out everything. Unset mode. I guess we would want to delete the mode. If M mode. Can I just do this, M mode? Or actually it might be what delete keyword, delete M mode. Do shared pointer dot data. Oh wait, no, I don't have to do this because of the ref counting. I mean, it's kind of the point. So when it gets down to when the Q shared pointer, like when there's no longer any references to it, it should actually declare the data. Should. So we are going to do this. Rip out all this. We no longer have that. M is available. Wow, that is much cleaner code. Where are the error? What's it saying? M is available. Yeah. M preferred is a null option. Oh, that's also something we should rip out. If I look at this, M preferred, M optional, so it should just be mode. Set preferred shouldn't even be a thing. So we don't actually need to override this. Equals what, delete? No, it's equals default, isn't it? We can rip this out. Turn up the music just a little bit. All right. It might be competing with me. Just let me try to get in between that. Whatever, that's good enough. Setters. Set preferred. Delete. So we have a set property, which just calls the parent ones. We have the set WLR mode, and they get WLR mode. And that's as simple as that needs to be, I think. But it does mean we need to clean up this logic even more, which fortunately there's, oh, actually there's a fair bit here. My God. All right, well. Let's see, current ZWLR mode changed event, I think can be deleted. Because that should be handled by the K. Wayland one. Assuming the two, you know. I think, yeah. I think I could delete this. Let me double check the logic here. I deleted it before, but I'd restored it just in case. So we get the size, and then we just do a bunch of state change things. So admit when, oh yeah, I guess we should have a state change for current mode changed. Let me actually fix that. Mode changed. Emit state changed. Which actually, I'm gonna do this. It's batch dot. I have the batcher stuff. Because M mark dirty will do the emit as well. Yeah. So we'll do M batcher dot mark dirty. Ooh, I could make this even fancier actually. I could do an M batcher dot batch, and the function will take in this. It'll take in current mode. I guess I'll meta mode, current mode. Let's see how well this works. Doesn't know what M current mode is. Cannot appear in capture list as is not a variable. Oh, that would have been a flaw anyways. Because that is on this. So we will actually do auto current mode is equal to current. Oh, we don't actually have a getter for current mode. In the generic one. No, we do. Get current mode. It just wasn't showing in the type complete. Do this. It has no idea what this is. M current mode of this is equal to existing mode. What is it flagging now? This. So that'll be batched up. Alright, so it's just complaining about that include being busted, I think. Because this mode changed. Or do we need another? There we go. Yeah, we were missing end curly brace there. So now, what the logic will enable us to do is batch the emit state changed and save if we are simultaneously changing current mode and preferred. And if we're only changing one, then well, only one changes, which is fine. And this, I think, actually could be set current. But I should have a set current mode. I don't. Okay, fine. Guess because it's only here anyways. All right. Because there's a bunch of this stuff. Refresh rate changed. Do we really have a dedicated thing for that? Refresh rate changed. The refresh rate change would change if the current monitor changed, if the current mode changed. Height changed. Width changed. Yeah, okay. Emit. Refresh rate changed. Meta mode. Refresh rate. Emit. Height changed. Meta mode. Size. Height. Emit width changed. Would be the size dot width. Like so. That would fix those. Modes changed needs to be emitted on the add mode. We would do emit modes changed. Because if we already have a mode, that would be fixed. So that fixes this, fixes width. I refresh current state. So those will be handled, which means this actually can go. So let's rip this out. Mode changed on this. We don't need mode added. We will handle for the construction of the WLR meta mode. Building Budgie on Vafu. Yeah, exactly. Yep, I'm capitalizing on it being a holiday. Damn right. Yeah. It's funny, like I slept in and then like I need to do a work thing anyways, like just it was a simple like change a config or whatever. So they wouldn't have to worry about it over the weekend. So did that because one of the guys is on like paternity leave. And then farted around a little bit with stream stuff. Couldn't get the Maker 2.1 to work. Apparently it doesn't support AV1. And yeah, just been working on this. Won't work on it for probably too much longer. Probably close it out around 3 hours. I know the wife wants to hang out. Understandable. Let's see, current mode. Current mode of the WLR meta mode. Which actually I can just rip these out. And save that. Because these will actually reference the WLR ones. And then I could be less precise here as well. Not that. That's too much. But we'll delete it there and then re-add it here, I think. Or is that actually going to be okay? That will actually be okay. All right, nice. That we need the Q shared pointer of. Unset modes. Yeah, we might need that. But let's walk through this incrementally. So, our meta head for WLR will construct the generic interface. We have a destructor here. We'll think about that one in a bit. Then we have the meta head here, which should get the WLR one. However, we have M head. We need M, I guess a Q shared pointer. Oh, this is funny. MWLR mode should actually be, I go here, type def, a Q list of the shared ones, like so. And then we should have a shared meta mode. Shared meta mode of M current. Current mode. That'll return that, so that gets cleaned up. What's it complaining about here? I'll do this. Oh, we do this. Boop, boop, boop. And then this here. All right. Has different returns. Yeah, because this is returning. This should be WLR modes, I think. And this is a different one as well. Yeah, because our generic interface has a get current mode. So this all should be get WLR modes by props. And they're not overrides. They just extend it. This we will override, I think. No, because that will be also just a generic one. So M current WLR mode, something like that. So if we take a look at all these, this needs to be get WLR current mode, which is going to return a shared meta mode. of M current WLR. The get WLR head, I don't think we need. It's the base class. We have get mode by props, which is going to be get WLR mode by props. So we iterate over all the M current modes, which is actually, I think, M WLR modes. If we don't have one, we skip for the height width. Oh, yes, I also want to standardize this. I want this to be Q size of size as well. So we're going to do Q size, size. And actually, oh wait, no, they can't be the same interface because you can, I forget, you could upcast, but the downcasting thing is not recommended apparently in C++. From what I've learned anyways. The optionals, they aren't ops at all. So we're gonna skip all this. So we are just trying to iterate over. We don't have a mode pointer. What? What is this even trying to do? So this would be the Q shared pointer. If this is null, auto mode is equal to mode pointer. I don't like it being called mode pointer. What shared mode? Shared mode. Dot data. That'll be that. And then if we'll do it like if mode dot size is equal to size, and it's like this. Mode size is equal to size and refresh. And we'll do mode refresh rate is equal to refresh. Then we return shared mode. Otherwise, we return nothing. And this is one of those things where I would just prefer it to be, this should be shared meta mode. And we're going to do this. Mode. We'll call it, what do we want to call it? Mode ref. We'll do this. Mode ref is equal to shared mode break, and then return mode ref instead of null pointer. So that'll fix that. Get WLR modes just returns the meta mode shared list, which is MWR output modes. M output modes. But this is a it's MWLR modes, right? MWLR modes. I have get WLR head, which returns just the head and then making the thing optional. Sure. Current mode. We don't need. Serial. Serial we don't need actually, and that's not even what is defined here? No, we don't. I don't think we need that because the identifier itself should be that. Set WLR head. Head finished. That and property changed, which hooks up to set property. And then we have unset modes, which is just calling, it's iterating over that. So this doesn't exist anymore. We have the slot. So now we should be down to, so we have our setter then. Where's our this? Right, submitted. Which this doesn't even, that shouldn't exist. So we should have 2 slots. One for add mode, which is this. So we create this and then we do output mode auto, output mode, set WLR mode as mode. Like that. WLR. Oh, already listened to the music again. All right, we're gonna have to go all the way back then to the beginning of the music. There we go. On meta mode, so this is a Q shared pointer of this, so we could just do this. And it's the same deal here, actually, Q shared pointer of that. Of adding a mode, and we construct this from output mode. Let's change all these references. This one here as well. We'll look through all this more deeply in a sec. I'm just trying to fix those. All right. Well, I guess we've already finished that. So we have the connect of done to the meta mode, which is when this would be availability changed. So when the availability has changed, availability change triggered for mode, found the existing mode. If it's the same as output mode, then we need to actually, so iterate over instead of this. Oh yeah, this is a bit of a tricky one, isn't it? We don't have the similar check here for when a mode has been announced multiple times in the generic meta head. So add mode for the K Wayland mode. So if it already exists, existing mode by props actually. If we have a mode matching this prop already, matching the properties already. Then what we're gonna do is do existing mode, set mode, of mode. So we're gonna reset the mode, reset mode. At this point, we know we don't have it. So this is similar logic where we construct it, then we iterate over the WLR ones actually. Because this, the mapping is going to be, I'm getting a strong sensation that we are going to have 2 different sets of modes. We're going to have the generic one from that, and then the generic one from this signal handler for add mode for when we have a mode added from WL output, and then another from the compositor, from the WL roots compositor. I mean, I don't think there's really any getting around that. Unless we overrode add mode, maybe? Though I don't think we actually need the dedicated WLR ones. Because we'd be stuffing it into a WLR, like the list would be the same, Not quite sure about that one. This one I feel a little stuck on. Like, of course, we need an actual reference to the WLR one for the current WLR mode. But the list, it would have to be that we check where is this being called? Add mode. This is being called on mode added on the connection of head, which is the WLR one. So whenever there is a mode added, what do we do here? We just emit mode added. Which goes to here, which is handled by add mode. Which is this not, hold on, is this not conflicting with the generic one? We now have a generic add mode. No, we do. How are these not conflicting? Add mode. And why is this private? Well, I mean, this should be called add WLR mode. I guess it doesn't really hurt at this point that it's private, but we'll do this. Add mode, add WLR mode. So in this situation, we want to create our, so we create our meta mode. We set, and this is our WLR one, which in turn is a generic one. We set the WLR mode, and then we create the shared meta mode, which is in turn the shared WLR meta mode. We connect to it on when it's done. Because we don't at this point have... Oh, yeah, because at this point we don't have the fucking information from the compositor. I mean, we do, but not through this protocol. So what I'm struggling with here is we will have all the information we need from the K-Wayland outputs because we wait for all those to be available. And as we're like, so if I open this up, I could show it. So we have like if I had a Wacom, this would actually be way easier. So we create the generic meta head as during setup. Before we even start handling WLR. At this point, we have all the meta. Actually, how am I? Didn't state. Yeah, how are we even doing it here? We're not even handling it yet here. I haven't even figured out this problem. I thought maybe I could lean on the problem solving of this, but no, I haven't even done that. Shit. We do add WLR head. I want to find... I don't really want to create the shared pointer yet. We return it here. Which we don't need to do. Just change this to void. Keep this simple. Unless we were calling it somewhere else, which is possible. Actually, I think it's quite likely. Like my line of thinking is we would, in this function, when the availability has changed, we have all the information from WLR about the size and the refresh rate. At which point we would check from the current modes, which we're doing here, right? But this is, these are like the generic ones. Then we're removing it. Delete the current one and add the new one. I don't want to do that. Like, I know this functionality is pretty new. Like, David had written that up to fix an issue, but I mean, I think my stuff will solve a whole host of other... All right, here's what we're gonna do. We're just gonna pretend all the other code doesn't exist, right? For const auto generic mode in modes. Get all the generic modes, see if one matches the properties of the WLR mode. If so, then I don't fucking know at this point. It's figured out from here. Generic. If generic mode dot height. Oh, that's output mode info. No. Current mode. God, I hate that. M current mode. M output modes. So this is no size. Does not equal output mode dot size. Or generic mode refresh rate not equal output mode dot refresh rate. Continue. If they don't match, skip. They don't match in size or refresh rate. Right. So at this point, we have a match. So generic mode is the matched one. What I think we need to do is do an auto out. I think it would be like this. WLR meta mode. This should be the WLR one. New WLR, actually casted WLR mode. Would we do it like this? Of course, the properties then get out of sync. All of this work just to have a frickin' ZWLR output head v1 really makes me want to just have our generic one. hold the reference as well. We create the head. Or we create the mode, I mean. Which is this generic thing. Well, not generic, I mean. Mode finished. Which we don't even use. That hooks up to our WLR meta mode. So we would need special logic for that. I don't know. I'm stuck on this one. No, I know not very thrilling content, but So this is the meta head. So actually, we should be looking at the meta mode here. Yeah, so it holds the reference to WLR mode, which is what holds the reference to mode. That's all it does, this meta mode. I really don't want, like, I really want the clean separation. I just don't know how I'm going to achieve it when we have all this. This connection. So we do the set output and then the mode add and mode change stuff. Because then I'm also concerned about race conditions here, where maybe we get the modes after the WLR ones have been emitted. And then we need logic in two places. So I think this is one of those things where I'm gonna have to chew on it off stream, I'm afraid, and brainstorm about it and play it around with different designs. But I feel like what I'm moving towards is a model where, well, this actually would all be solved. If I take a look at the protocol, I mean, we have the set current mode, right? Set custom mode. If we never used set mode with the reference to the ZWLR output mode v1, then we would not need to hold the reference to any of that, right? We would just be always setting a custom mode. So in that case, we wouldn't need WLR mode because we're not interested in the properties from that. Like, we just not something we're interested in. Of course, I feel like aren't we gonna just be having to deal with this problem when we implement KDE output management device v2 as well? Oh, what a pain. So if we take a shortcut now in not implementing this properly, we're gonna have to do it we're gonna have to implement it properly when we implement it as the KDE output device v2 support for KDE output management. So there's no shortcuts, it seems. It's like we could we're not using the properties, are we? What are we doing with these? Meta mode. We just set preferred. This changed logic is dumb. We don't need that. And then we're just holding off on this. So we are holding off on the availability change. That's the only thing. So if we don't have a refresh rate or we don't have a size, so if we have both of those, we know it's available for use. And then that set availability is actually on the base meta mode. So do we need any of this? Let me take a look at our generic meta mode. So we are doing set. So when we do a set mode, we know we have all the properties, and then we do the availability changed. So I feel like this logic that we have in meta head, the WLR one, because we have this mode added, a mode changed. The mode added one, we should not be adding it immediately. Availability change. Do we have current availability changes available? But we're not actually storing that. I really don't like this being called availability changed either. Let me see. Is it just the... It should even... Well, whatever. Dbus part aside. Yeah, okay. I need to fix all this, but I'm going to rename it to ready, I think. For starters. So let's do that. This is ready. We'll have this down here. And then the dbus schema for output mode. Ready changed. Ready changed. And we will have a new thing called mReady. mReady. Ready changed. Okay. What's going on here? Meta mode. Out of line definition. Yeah, it's because we're no longer allowing this. It has to be called separately. Okay. So at that point, the logic related to adding that up. Meta head, which is the generic one. So we add the mode, which is this. Get the existing mode. We already know it's ready, so we just reset the mode there. Like, that's all fine. We create a new one, set a mode, and we have this append. But what I think we should do is if We need logic here in meta head for when the mode is ready. So we have virtual void mode ready. And this is going to be our shared meta mode. Fucking hell. Mode. Like so. Move the, there we go. Share meta mode. Because all this stuff should be in that. This is doing my head in. Must admit. There we go. The mode. Void meta head. Mode ready. This is going to take in a shared meta mode called mode. After which point we then append it. And well, actually, no, it would be mode ready of just a meta mode, wouldn't it? Meta mode. Like this. So I think it would be something like this. The problem is this add mode is, oh, fuck. We have this as part of the mode change where, you know, if it doesn't exist, we add the mode. But of course it's, yeah. It's not always going to be the case. But the assumption is made that in our current mode, right? Like if I go up here to mode changed. If it's null, I would say, you know what, if it's null, then we just return. If this Wayland mode doesn't have an existing meta mode, return. Of course, then you could make the argument maybe all this should be changed, you know? If it's current, then the current mode setter should have this logic. One could argue. Mode changed, mode ready. And this emits mode changed. Wait, oh, mode's changed, right? Yeah, because we add it. At this point, we construct it and then we add. But this has to be a void. Unfortunately. So we add a mode and then we just return. Otherwise, we create a new meta mode. We set the Wayland mode to the meta mode. And then we'll have the handlers. On the meta mode. Which is this. right? We'll do if it's meta mode ready. So we need on meta mode. Virtual bool ready. Set ready, which would do a ready changed. Set ready. And then ready change, which then returns that. Something like that. Set ready of true. That is us informing that it's ready. And do we have a no full meta mode ready const of return m ready. So if it's ready, then we would do immediately the if it is already ready, we will do the construction of the auto. So auto shared mode is equal to shared meta mode. Oh wait, no, actually we will just immediately call mode ready on meta mode. Call the mode ready. Signal. Gee, it says slot. Slot on meta mode. Or for this meta mode. For this meta mode. Otherwise, not yet ready. We're gonna connect meta mode K-Wayland. No, not K-Wayland. Meta mode. Alright, I'm gonna do the whole outputs. Meta mode ready changed to be this. Ready change is actually only doing the bool ready like that. So we need to do this and meta mode, where we then do mode ready on meta mode. Connect. Not ready yet. Hook up to the meta modes ready changed. Signal. So something like that. And then I'm so deep in the rabbit hole. Why did I even do that? Something related to the frickin' meta mode, wasn't it? The property events would then emit the ready change event when everything is ready, which would then have to be handled by WLR property change when it's ready. Yeah. We need to find from the M outputs. I feel like this M, I feel like the WLR meta mode should, guess if I cast it, does casting a class, like if you had class A and you class B, you classed it A to B, and you made changes on B, does that actually apply to A? That I don't know. And that is going to have to wait until, I think it's going to have to wait until another day. Because I want to have a little bit of a Friday holiday. And not do too much. But hey, now that actually, this time I'm doing an outro that's actually going to have, have my screen on display, which will be handy. So, if you'd like to follow along on the journey related to Buddies of Budgie, we haven't posted a news article in a little bit. This is March, but we'll get one out, sort of as an update. There's not really any blockers, I think, at this point. It's just a lot of people, including myself, were busy with OS stuff. But you're welcome to support us and our endeavors on developing Budgie 11 by heading on over to Buddies of Budgie. And of course, you know, just spread the good news about Budgie. That's always helpful. But if you'd like to financially support us, we're available on opencollective.com. So fortunately, we have quite a set of budget here. So I wouldn't worry too much, assuming you are to begin with. But it does go a long way to supporting us and our dream of one day working on it full time. But I don't think it's going to happen yet. Maybe for B11, that'd be awesome. But what it does help with is our Forge. So all of Budgie 11 is developed on our Forgeo instance. So we're not developing on GitHub. There's a whole reason for that. If you go to our news and State of the Budgie for 2025, we actually dive into our move to Forgeo for all things Budgie 11, including for the site. So like anything that realistically could be moved over there has been or is planned to be, such as Budgie backgrounds. But in some of the cases, like Budgie desktop itself, so this is like Budgie 1010, that is still on GitHub. But that's because, you know, all the issues are filed there and it's just easier to manage on that. But for Budgie 11, it's going to be on our Forge, where we also have our own CI/CD leveraging Woodpecker. And this is all running on ARM. So both Woodpecker itself is running on ARM hardware and the builder. And that is important because we want to support multi-arch. So we want to support x86-64. We want to support ARM. So this is like ARMv8, ARM64, and also RISC-V down the line when hardware is obtainable, like memory prices. So we will be ending it here. Oh, sorry, Heartless Caesar dropping in just as I am ending the stream. But don't worry, because this will be also on our YouTube channel. So it will be at Buddies of Budgie. So if I go over here, you can see that while we are live already, while we have been live. And in addition to that, we are also on MakerTube. So if I head on over to MakerTube, and funnily enough, actually I need to fix this because it should actually show, oh, it is private. I have been uploading the videos. This actually should be deleted. We'll go ahead and we'll delete this. Delete number 6 there. So this is actually in my library. So you could actually, if you aren't the biggest fan of YouTube, which is kind of funny because, you know, most of the people that would be watching would be on YouTube, you can, of course, use the MakerTube, or you could use any PeerTube instance and watch our content, which is hosted kindly by MakerTube. So that's a little inside baseball. It hasn't been announced yet because I've been waiting to upload all the content, which I can do shortly after. I'm going to make this public, actually, as a matter of fact. And if I head on over to our channel here, which is going to be Buddies of Budgie. So if I go to channel, It's makertube.net/c/buddies of Budgie. You can see we have all the building Budgie 11 videos, and I will be uploading all the old Magpie ones. So some of the stuff related to like the old workshop videos, I'm probably not going to rehost those just because I want to be a little cognizant of the storage constraints or any storage constraints, even though I financially support MakerTube. But yeah, it's another option, and I'll be updating our website soon enough to actually link to that for our PeerTube support. Just found the channel, make sure to watch later. Fair enough. So this video itself will be unlisted, but I will trim out the beginning and all that as I usually do, and I re-upload it. So I re-upload it without like this so much of the starting soon, and sometimes a little bit of the outro cut as well. So yeah, hopefully next time things will go better for the multi-stream. Unfortunately, I wasn't aware that PeerTube doesn't seem to support AV1 for streaming, which I use, so I need to set up like multiple encoders, one for YouTube and one for MakerTube. So I will be streaming to that simultaneously on the next stream as well. So yeah, thanks everybody for watching. You guys have a good one. So bye bye.